So this question is using our functions and function notation. So the price of gas at Lyon's gas station is $1.50 per litre, and a customer is buying a minimum of 10 litres, then you get $5 off as a deduction for a discount applied. So they tell us the formula for that. So 1.5, which is the price per litre, so X is the number of litres, minus 5, and it only works when X is bigger than or equal to 10 because the discount only works when I buy a minimum of 10. So the first part is finding the total cost of buying 40 litres. So what we're doing here is just finding what happens when X is equal to 40. Okay, that's all it's asking us to do. So the notation for this is L of 40 rather than L of X, and that's equal to, so if I replace the X with 40, then I replace the X with 40. Okay, so that's essentially what I'm doing there. So 1.5 times 40, and then minus the 5 at the end. Okay, and if I type that in, or you can do it in your head, whichever, you would get $55. So it's $55 there for the first one. And then the second question is finding the inverse function. So this with the minus 1 is the inverse function. Okay, so it's where we swap the X and Y values and then we rearrange them. And to do this one, it's substituting in 70. Now, the inverse function, as I've said, swaps the X and Y. So if we have the original function, we have the domain, which is the X value, and the range, which is the Y value. In the inverse, the domain and the range swap. So essentially, you end up with this. Okay. Therefore, if I'm finding L minus 1 of 70, that's where I'm substituting into the domain 70. That's the same as using the original function and making it equal to 70. Okay, because it's the opposite way around. So there's two ways to do this. The first way is to find the inverse function, which is a little bit more work, and then substituting the 70 in. The other method is just swapping them round straight away. Okay, so I'll show you both methods here. So the first one is to actually find what is the inverse function. Okay, so to find the inverse function, at the moment we have essentially y is equal to 1.50 x minus 5. So we're going to swap the x and y. And then we're going to rearrange it to make y the subject, which is what we would normally have. So dividing by 1.5. So the inverse function is this bit here. Okay, so x plus 5 divided by 1.50. That's the inverse function. And we want to find the inverse function when the x value is 70. Okay, so we can then substitute in when x is 70. So we have 70 plus 5 over 1.5. So that then gives me 50. The other method to do it is to, as I say, swap round the domain and the range when you do the inverse. Okay, in which case we're just substituting a range or a y value of 70 into the original function. So the original function was 1.50 of x minus 5, and we want to make that equal to 70, and then you can end solve that, in which case you then find 50 as your value of x, and you can just use end solve. So either of those methods is fine. Personally, this method is easier and quicker, but it requires you to remember and understand how these swap. If not, you can just find the inverse function and then use that method. So part C, the price of gas at Erica's station is 1.3 per litre, and a customer needs to buy a minimum of 10 litres. And they're saying that Erica's gas station is cheaper than Leon's, the first one, when X is bigger than K. We need to find that value. So in order to answer this question, we're basically thinking about these two different functions. The first one is 1.50 x minus 5. And the second one, Erica's, is 1.30. And we don't get a discount, so it's just 1.30. So what we're going to do is actually use our GDC here to plot them and see what the two graphs look like. So the first one is 1.5 x minus 5. Oops. Minus 5. So that's the first one, which is Leon's. And the second one, so if I press tab, I can draw a second function, is 1.3x. There we go. And we can see here, we obviously need to change our scale. Let's go up to 50. That there is a point here where Erica's, the red one, becomes less money than the blue one. So it starts off being more expensive, and then there's this point where it becomes cheaper. Okay, so to find that point, we're going to analyze the graph and find the intersection. We've got the lower bound somewhere down here, the upper bound somewhere down here. So just picking something either side, and we can see there that it happens at 25. And that's what the question's asking us to find there. It's saying where x is bigger than k, so there's this value of the intersection. So anytime you see a question like that, you're basically looking for that intersection value. And it's where k is equal to 25. And you're working out to show that would be a very rough sketch of the two things. Okay, so we want to go from 0 there. So yeah, something like that, just so that we can see what's happening. So Erica's obviously goes through, and Leon's kind of does that. And this happens at 25, 32.5. And that would be enough there, so long as you labelled it up. Leon, Erica, and this is your function of, or cost, you could call it what you need to call it, and this is your x value. Okay, so as long as you drew a quick sketch there, then that would be enough work.